How do you find the polynomial function that models a table of values using the finite difference method? Well, let's take a look. So in this table, you see that x's are going up at a constant rate. They're going up by 1, 1, 1, 1, 1. So using the finite difference method, what you do is you find the differences in your y values, and you keep on finding the differences until you get the same number. In other words, a finite number. So if you do 12 minus the difference between 12 and 11, you subtract 1. To get from 11 to 6, you subtract 5. 6 to negative 3, you subtract 9. Negative 3 to 16, you subtract 13. And negative 16 to negative 33, you subtract 17. So these are not the same number. So now you go again. So negative 1 to negative 5, you subtract 4, negative 5 to negative 9. And now we're getting a difference of the same number. So the negative 4 has nothing to do with the actual equation. I'm not going to see negative 4. Maybe I will by chance. But the negative 4 tells me I have the same number, and it took me 2 sets of differences to get there. So 1 set of differences, 2 sets of differences. So 2 sets of differences tells me that my polynomial is a degree 2 polynomial. And then looking at my general forms over here, a degree 2 polynomial is of the form y equals ax squared plus bx plus c. So then I write that down. Y equals ax squared plus bx plus c. If we had 3 sets of differences, it would be a degree 3, and this would be my general form. Okay, so this is the equation that we want. What we have is 3 unknown values. I don't know what A is, I don't know what B is, I don't know what C is. So what we're going to be doing is setting up a system of equations and solving using matrices. And since I have 3 unknown values, I'm going to have a 3 by 1 matrix, which means I need a 3 by 3 matrix to match that. So I'm going to pick 3 points from my table and plug them in. I have x's and y's. I'm going to plug them in for x here, here, and the y value there. So however many unknowns you have is how many points you're going to pick, which is going to be how many equations you come up with. So I'm going to pick my first 3 points, and what I do is I write down the ordered pair, and then I plug in that ordered pair into my equation right up here. So 12 is the y, 1 is the x. So 12 equals a times 1 squared plus b times 1 plus c. Simplifying, 12 equals 1 squared. We have 1a plus 1b plus c. I'm just going to put a 1 in front of that to help me keep track. So here's one equation. Then I'm going to use 211. Similar fashion, plugging in 2 for x, 11 for y. 11 equals a times 2 squared plus b times 2 plus c. Simplifying, 2 squared, here we have 4a plus 2b plus 1c. Here's my second equation. Third point, 3, 6, is going to give me my third equation. 6 equals a times 3 squared plus b times 3 plus c. So 6 equals 9a plus 3b plus 1c. And there's my third equation. So using these 3 equations, I have a system of equations. So we have 1a plus 1b plus 1c equals 12. That's my first equation. Second equation, 4a plus 2b plus 1c equals 11. Third equation is 9a plus 3b plus 1c equals 6. So now, to solve a system of 3 equations, what we do is we set up a matrix equation. We learned how to solve matrix equations back in Unit 3. Your first matrix is going to be all of your coefficients. So each coefficient over there in the same order that you see them times your variable matrix, A, B, C, equals your constant matrix, 12, 11, 6. And now you can solve this. You're going to plug this matrix in your calculator as matrix A. This matrix goes in your calculator as matrix B. To get your answer, to get what A, B, C equals, you're going to find the inverse of matrix A, multiply it to both sides. I do not need to see that work. You can just do this all in your calculator. Your answer is going to be A inverse times B. So when you do that, you get the matrix -2, 5, and 9. This is not my final answer. My final answer, I go back up here. We now know A, we now know B, we now know C. So our final equation, y equals -2x squared plus 5x plus 9, and we have our final equation.